All right, welcome to example 3, where this one, we're just going to solve differential equation, but we have an initial value, and so we're able to actually find what our constant's going to be, so we'll be able to find the solution over the given initial value. And again, we also want to find the largest interval I over which the solution is defined, so let's go ahead and work on this one. So here, the first thing that we're going to do is we're going to divide everything by y, and so first, let me show you. So again, this one's a little bit different. The independent variable this time is, the way it's written is that we took the derivative with respect to y based off of x. And so this, instead of having dy over dx, is dx over dy. So then our, differential equation in standard form is going to be looking at something like this. So dx over dy plus p of y times x is equal to some function of y, just because the independent dependent variable switched. All right, so to get it in this form, we're going to divide everything up here by y. So then we're just going to get dx over dy minus, I'm going to say 1 over y times x, and that's equal to dividing that y squared by y, so I'm just going to get 2y. Now, the integrating factor is going to be our p of y, which is negative 1 over y. So I have e to the integral negative 1 over y dy that's our integrating factor. So again, you can go ahead and write this as in our form, except for this is going to be d over dy times, and then we have e to the integrating factor, e to the integral of negative 1 over y dy times x, and that's equal to the integrating factor times 2y. Now, let's go ahead and find the solution to this integrating factor, which isn't bad. It's going to be e to the, I'm going to integrate negative 1 over y, so it's going to be negative natural log y. All right, and again, that's just going to be e to the natural log, and that's going to be times y to the negative 1. We got to get that negative out so that we can cancel out this e to the natural log. So that's just going to be y to the negative 1, or 1 over y. All right, so now we're going to go ahead and we found what our integrating factor really is, and so now we can rewrite this as d over dy times 1 over y times x is equal to 1 over y times 2y. And so we do that. Now we want to integrate both sides as well, so we're going to, let me change the color to blue. So we're going to integrate the left side and the right side, this time with respect to y. And what's going to happen is we're left with 1 over y times x on the left-hand side. On the right-hand side, we're going to take the integral of just 2, because the y's are going to cancel out dy. When we do that, we get 1 over y x is equal to, looks like 2y plus c. And then we're going to get rid of that 1 over y by multiplying everything by y. So x is equal to 2y squared plus cy. Now, let's look at the interval. Is there any time we had y in a place that could give us something that we want, like in a denominator, which we do? There, also there. So we know that y cannot equal 0. So we have, intervals from negative infinity to 0 and 0 to infinity. Those are our largest intervals. So we can choose which one we want. It doesn't matter, like just deal with positive, so 0 to infinity is the one that we can choose. Now, well, actually, we're going to have to choose this, I'm sorry, because of our initial conditions. Because we're getting 5 for y. When x is 1, we're going to have to be from 0 to infinity. All right. So, let me go ahead and highlight that one, because that's the one that we're going to be able to use. All right, so now let's go ahead and solve. So this is y of x equals, 5, and so our x is 1, so 1 equals 2 times 5 squared plus c times 5. Solve for that, it's going to be 50, so 1 equals 50 plus 5c. Plenty of room. So subtract 50, get negative 49 is equal to 5c. Also, I want you to notice that this would be the term that we have to check to see if it's transient. And again, that's not going to go to 0 when y goes off to infinity, so we don't have a transient term there. And so when we don't have a transient term, it's called a steady state term. All right, so just give you that. So 5c, divide both sides by 5, so c is equal to negative 49 over c. And so then our differential equation is going to be, or sorry, not different, but the solution is going to be x is equal to 2y squared minus, I don't know why I said c there, it should be a 5. No, that's ugly. There we go. All right. And so 2y squared minus 49 over 5 times ry. And so there's the solution to our differential equation where, again, we're from 0 to infinity.